The types of RFCs. So this is one of the theoretical topic. Also, some of the transactional codes also involved here. So there are the types of RFC connections are there. So can someone explain how many types of RFC connections we have? First of all, where to create the RFC connections? What is the transaction code?
SM59.
Yeah, right. SM59 is the transaction code to create the RFC connection. So how many types of connection types RFC?
Like ABAP to ABAP and ABAP to external, ABAP to TCP or IP. 3 types of connections we have.
Yeah, so that's great. So we have types of connections are, so there are the 6 types of connections, right? ABAP to ABAP connection. So TCP IP connection, external connections, internal connections, ABAP drivers connections. So there are the types. So these are the types of connections are there here. If you go to the SM59, you can see all the details here. TCP, internal connections, HTTP. There are the types of connections are there here, right? So here types of connections are there. So these are the RFC connections here. So there are the some types also available, RFC types of RFCs here. There are the 4 types of RFCs. Those are the connection types. This is the RFC. So types of RFCs here. So normally why we use RFCs? To transfer the data from one system to another system to communicate. So via this RFC, the data transfer will happen. So how the via wire, electrical wire, how the current will pass to from switchboard to the fan or light. Same way via RFC destination, your data transformation will happen, right? So it's a so RFC is a one of the remote function call. The type of function module is used to communicate within the SAP system or outside of the SAP system using the protocols. It will use the using the protocols here, right? So in SM59 we can create it here. There are the few types of RFCs are available. They are one is the synchronous RFC, sync RFC. The second one is the asynchronous RFC here, async RFC. The third one is called the transactional. So transactional RFC. The fourth one is called the queued RFC. The queued RFC here. The queued RFC here. There are the 4 types of RFC connections are there in SAP, right? So coming to the synchronous. So let's go into the each and every type. So some detailed debate. Okay. So synchronous RFC, sync, right? So what is mean by synchronous RFC here? Synchronous RFC is like a two-way communication. Two-way communication. Two-way communication means, suppose example, this is the one system. Here is the one system here. You established a RFC destination from one system to another system here, right? So this will send the message. So this will send the data. So data will go from here to here. The data is followed to the one system to one SAP system to another SAP system here. Immediately, the second SAP system will receive the data, the target. It will send the acknowledgement back to primary saying that, so primary or first system saying that I received the transaction. Then immediately it will send the one more transaction. It will give the response, which means the synchronous RFC is like a two-way communication. Once the message reached or to the system or the program will get the acknowledgement. If the target system is not, if the target system is not the reliable communication, it will go to the sleep mode. Or target system is not available, it will go to the sleep mode here, right? until target system is available, your system is the resources are keep on sleep mode only here. Once the system is available, we'll start the flow again here. So this RFC is bit costly when we because so both the systems are should be available at the same time, right? Both the systems are available at the same time here, right? So when you're transferring the data from this system to second system, the first system to second system here, so what exactly happens here? So you are sending the data, it will receive via RFC destination, it will receive the data here. Once the data is received, it will send the acknowledgement like, so hi boss, I have received the transaction. Then your first system will transfer the one more data. It will send the acknowledgement. It will send the same as like, so previously we had some mobile phones, right? Not the I touch previously we had in the phones, when you send the message to your friend, you will get the, so your message has been successfully delivered. You will get the one acknowledgement. Then you will send the one more text message, right? So we have that mobiles, right? Nowadays, mobile, we are not using any messages in WhatsApp, everything we are using. But we have the messages option also. If you send the message, you are not getting, you will not get any option. Delivered, like that, we will get the one deep sound, right? So, but that is called the synchronous RFC here, which means source will send the data to the target will send the acknowledgement back to primary first system saying that I received it. That this way, the both the systems are should be available at the same time. Both the systems are should be available at the same time here, right? That is the synchronous. Synchronous means it will wait for the acknowledgement, but asynchronous is the reverse of the asynchronous. So which means asynchronous RFC will not wait for the acknowledgement here. So the best example of the asynchronous RFC is here. So it will send the it will send the message. It will send the message to the secondary, right? It will send the message to the secondary. The secondary means second system. Second system will not send any the response back to primary. So because whether it's received or not, it will not bother. It will keep on sending the messages to the secondary. Keep on sending the message to the message to the this one, right? So this is the one thing here. So which means the best example which I have seen in one of the which everybody knows. Best example of the asynchronous RFC is the, so everybody knows, so one side love, which means so this person is keep on sending the messages to this person, she is not responding. It is called the asynchronous RFC here, right? So we don't know whether the message is received or not, and so she is responding or not, we are not sure, right? So it's not the reliable communication. It's kind of one-side love, right? So that is called the asynchronous RFC. Synchronous RFC. So you are sending the messages to the second system. Second system will send the response back to acknowledgement. I means acknowledgement back to the primary saying that I received it. Then immediately one more transaction, one more data, like that. It will keep on sending the data to the second system. That is called the synchronous. Asynchronous is reverse order, only one-way communication, right? It's keep on sending whether not sure whether you received or not here, right? That is the one. The next one is the transactional RFC. So the transactional RFC is a advanced version of the, this is a advanced version of the ARFC. Means asynchronous. This is the advanced version of the ARFC, same as like ARFC, but when the sending the transaction from first system to second system, so it will create a one transaction ID for each and every transaction. So there these transactions IDs are maintained. The transactions ID will be generated by source system. The transaction ID will be generated by the source system here, right? So these transaction IDs are maintained under the SM58 transaction code, where we can see the transaction and also the reached target system, recipient system here. So we can see it here, right? The example, user is created a main client, it will distribute the client dependent and everything, right? So maybe that is the not the best example, but only thing is here, when you are sending the data from here to here in the source, it will create the transaction ID. source, we will create the transaction ID. So via this transaction ID, data will go to the second system. So it will ensure that there are no duplicates received by the receiver system. This is a sender system. This is a receiver system. Ensure that the sender system is not sending the duplicate transactions and everything here. So for the transactional RFC, we have the transaction code that is called the SM58. SM58 is the transaction code. There we can see any transactional RFCs are failed or not. We can see it here. If you go to the SM58, so here we can see the any transactions are failed in the system or not. We can see it here. If you go to the SM transactional RFCs, here you will get the list of transaction IDs. So it's in case of any transactions are posted. So, but in this system, in ECP, you will get the transaction ID. See, there are a lot of transactions are failed. So each and every transaction, there is a ID is generated. There is a transaction ID is generated here. So from which system this is transferring, which system this is going. This is going to the target system. These are the target systems. All the transactions are going to the target systems here. Target systems here. This is the one, right? These all are going to the target systems here. Target systems here. That is the one thing here. In the SM58, we can find out the transactional RFC. So this transaction, each and every transaction, whatever the users are done the transaction, it will create a one transaction ID. Suppose this is the caller. Caller means user. So this is the user. He done the one transaction code. But the transaction you should send to the target system is the this is the one. So target system is RFC destination. It should send to the target system here. But this target system is not exist. So then the transaction got stuck here. So what is the transaction? What is the data? Why? Because inside of the transaction there is a data. There is a data. We cannot see it here. It is in the binary code. We cannot see it here. So there is some data here in the binary format, right? This data is sending to the target system. The target system is not available. Still, the transactions are stuck in the SAP system itself. SAP system itself, the transactions are got stuck, right? So there is a one more user, one more user, one more user. They are like that. They are the number of users here. Number of users here. Number of target systems. It is sending to the target system here, right? This is the target system. It is sending to the target system. There is no target system is available. So that is the thing of the transactional RFC here. So which means there are no duplicates of the receiver. Each and every transaction, one transaction ID will be generated. In case of the transaction is, so in case of target is not available, the transaction code will start in source itself, as I see now, right? So in case of the transaction, target is not available, that source will keep the transactions in the source system itself. So there is a program there is a job actually. It will every 60 seconds it will keep on sending the data. It will run every 60 seconds. It will send it to here, right? So the main thing of the transactional ID, it is also does not require any acknowledgement. But so if the target system is not available also, it will keep on sending the data to the target system. So when the target system is available, so then it will send that data to the target system here. Source will send the data to target system here. But only thing is the for this one asynchronous RFC, transactional RFC difference is the asynchronous RFC there is no transaction ID. But synchronous transactional RFC, there is a transaction ID created for each and every transaction. In this way, already the transaction received by the target system, it will say like already received it, duplicate data. If not, then it will send the transaction to the target system. In this way, we can avoid the duplicate of the data in the target system and everything here, right? That is the transactional RFC. Okay, so we have the transactional code. The queued RFC. Queued RFC is like a advanced version of the transactional RFC here. Transactional RFCs ensure that the queues are like a transaction is committed based upon the queue order. So this will ensure the consistency of the the data transmissions, reliability of the data transformation and everything here, reliability of the data transformations and everything here, right? So means this is a just it will send the transaction ID, but this one it will send the transactions in a order wise it will send the data. Order means which order means before order, first in first out order. Queues via queues. So via queues it will send the data to the target system here, right? Via queued RFC. Queues wise it will send the data to target system here, right? So when sending the data to the target system here, so queue wise there are the queues here, queues mechanism, right? So why? Because all the data is going to the target system, but there is a order of the flowing the data, right? There is a order. So when you are using the queued RFC, it will send the by order of sending the data here. So in SAP, there are the orders, like where can we create the queues and everything means in SMQ1, SMQ2. SMQ1 and SMQ2 here. SMQ1, SMQ2 are the transaction codes here. Here we can, this is the outbound queues. Outbound queues here, which are going outside of the system here. So then, so next one is the inbound queues here, which is coming inside of the, so inside of the queues here, right? Which is coming inside of the queues here. Interfaces monitoring inbound queues, which is coming inside of the system here. So inside of the system here. So here in SMQ1, SMQ2, we can see it here. Go to the, so SMQ1, we can see the outbound. SMQ1 outbound, we can see it here. So any outbound messages are failed or not. So client queue name start, click on the OK. Here you will get the details. Here you will get the details. If any messages are failed in the system or not, it will say the details here. You can see some GRC related, some 7,000 entries got stuck here. In this queue, 7,000 entries got stuck in the GRC. In this queue, they are the 7,000 entries got stuck in the GRC system here. Right? You see, there is a 7,000 entries got stuck in the system. Right? So this is the target system. Destinations means this is the so target system here. GRC1, this is the target system here. 7,000 entries got stuck by the user here. So right. So that is the one thing here. So same as like here, other systems also available. You see, other systems, other clients, other transactions, ABO, many systems are there here. Many systems are there here. Right. So here, this is the main thing here. So here, queue wise, these all are the queues. These all are the queues here. These all are the queues here. CF star queues, CS star queues, all are the queues here, right? So via queues, it will transfer the data to the respective outbound, which is going outside of the system here. Outbound means which is going outside of the system, right? So SMQ2, which means inbound queue, which is coming inside of the system. Inside means within the same system here. Only three queue entries got stuck here. Only three queues are stuck in the SAP system here. See, only three queues are stuck here. That queue got stopped here. Just we can see unlock the queue here. In case of any entry, normally unlock the queue here. Just refresh, the queue entry will be gone. The queue entry will be gone here. So, okay, the queues. Sir, where to define these queues and order, right? So normally in SMQR, this queues creation, the order creation, everything we do here, SMQR. So here we can define the inbound queues inbound queues creation, SMQS, outbound queues creation here, SMQR. Or here we can create the queues here. You can see the queues here. There are the multiple queues are there here. Multiple queues we can create it here. A star, B star. So some queues we can create it here. Purchase requisitions. So some queues, XB star queues. There are the many queues we can create it here. Right? So this we can do it in the SMQR. SMQS. It is the outbound scheduler, outbound queues, which is going outside of the system. Outside means our SAP system, right? Outside means another SAP system here. So that's the reason we can use the this scheduler here, outbound scheduler. So you can see the queues are there, destinations are there here. Via these destinations, data transformation will happen. Via destination, the data transformation will happen to the target system here, right? Which is going out, which is coming in. In means within the system. So that is called the outbound and inbound queues here. So when the data transferring is happening here, so this is the system, source system. This is the target system here. So this is called the outbound queues. This is called the out, which is going outbound queue. This is called the inbound, which is coming inside of the system, right? So what will happen? So data which is coming here, which will come to here, then via it will do some editing here, then it will go to the outbound, then outbound to here inbound, then inbound to the system here, then system to here, then again it will come to in this flow, it will come to in this system here. So which means data will fluctuate from one to other, another to another, data will fluctuate here, right? That will happen in the system here. This is called the, so the data flow mechanism, how the data flow will happen, one system to the another system, how the data flow happen. This is the way your data transformation will happen to the target system here, right? So this is called the outbound. This is called the outbound mechanism, outbound. This is called the inbound, which is coming inside of the system, right? This is called the inbound, outbound and inbound mechanism. Yep. So outbound means the system is sending to the other system. Outbound means via RFC destination, it will send it out. So that is the reason if any outbound connections are there, so then we can configure via RFC destinations here. Via RFC destination, we can create it here. Suppose like if we want to register the one more connection, then via RFC destination, we have to create it here. Via RFC destinations, we need to create it here. That is what we have to do it in the system. Suppose like you want to send it to the ECD CLNT 100 client, then we can send the data to the ECD system here. There is a ECD client is created here, right? So like that, we can create the connection here, right? Outbound. SMQR, which means inbound scheduler, queues creation. You go to the registration. So you want to create the XC star queues. Normally this will be created by the our team. Then here some MCEX queues, right? MCEX queues. So like that we can create the queues here. So who will define this queues means functional team will define the queues here. They will tell you the order of the processing the queues in here. So via this queue means order, right? Via this queue, data will come to the inside of the system. There are the multiple queues. Via this queues, data will come to the so order-wise, this is a reliable communication. Data transfer will happen here. This is the source. This is the target system here. This way, the queues works here. The queues defining queues creation, order, everything we can do SMQR, SMQS. Then to monitor whether how many entries got stuck, whether entries are processing or not, we can see in the SMQ1 and SMQ2, we can see it here. We can see the connection test and everything here in the SMQ1 and SMQ2. Okay, this is the inbound and outbound queues. That is called the queued RFC. Queue wise, order wise, it will transfer the data to the target system. Transactional RFC, right? Transactions. Asynchronous RFC, synchronous RFC, it will happen each and everything here, right? That is the main purpose of the data here, right? So here, so one more thing here. So when I suppose example, this is the demo system. This is where we have the data, actual data is we are having the data. But when you see the other system, suppose ECD, we don't have any queues. Why? Because this is a newly built system. We don't have any queues and everything here. Nothing is there here. So in that case, we have to define the queues here. We have to define the queues and everything. We have to define it. That is what we have to do it. Okay, that is what we have to define it here. There is no queues, order, no entries, anything. This is the one of the demo system. That's why you can see the data. That's why you can see the data inside of the systems and everything here. That's why this is the one of the demo systems here. So that is the reason you can see the data. So stuck entries and everything, you can see it here. How many entries got stuck here? So all the information you can see it here. All the information you can see it here, right? So this is the one of the thing here. So GRC. So GRC, one of the system got stuck here, right? ECC to GRC, one of the system got stuck here. So like this, we can see the transactions and everything here, right? That is the main thing of the systems here. So yeah, that is the queues related and the types of RFC connections and everything here. Okay. Any questions, anyone? It's a small concept actually.
So do you limit the duplicate transactions in the configuration, or it will be handled by itself?
Your duplicate transactions means here system will system will check here before transferring the data to the target system. So system, so each and every transaction, SAP will assign a one transaction ID. So if the transaction already reached to the target system, SAP will tell like this is a duplicate transaction. I cannot send this transaction to the target system. Then in this case, functional team will cross check. So they will take the decision like, so removal of the entry. So all those things they will take care of that. So it's there. Or it is if anything got stuck here. So any RFC connection issues, any technical issues, we can fix it out. Connectivity is not possible, target system is not available, we can bring up the system and everything. That kind of things we can do. So anything related data, the decision making is done by the functional team. So as part of the daily activity, if you see this kind of errors in the SM58, so you can just take the screen capture of the screen, just send an email to their functional team. So they will take care of the respective action. Because they are the responsible for the data. We are only technical related issues. See, this is the target is not available. Target is not available means, so the target is not available. This target system is not available. So here in this case, we need to go to the SM59. So then you can create the one target system here. So there is a PS underscore. This kind of things we can do that. So PS. Suppose like here. What they can do here, we can edit the system, target system, KPONLINE 102. So I'm giving the ECD system details here. Fairly remote. So I need to configure host name. So like this, so if any technical problems that we have to take care. So if any other problem, then SAP will take care of that problem. Like SAP means functional team will take care of the data related issues. If the RFC destination is not working, something is not working, which we have to take care, which we have to work on the systems.
Sir, instance 00 for KP online 1 because for newly configured there.
I think ECD, right? We are connecting to
Yes, yes. Yeah.
it's 02, right? 02.
0, 0.
00 is for the NW1. ECD
Okay.
is the 02.
Okay.
So this is the destination, which is not available. Okay. What I can do here, let's copy the same destination and go to SM59. Click on the create button, like free connection. So 02. So client 100 client user. You can say basis and the password you can maintain. Connection test will fail. I know. Yeah. So user we created now. We created the one user here. So an RFC destination we created. So when you transfer the data to this RFC destination, so via this RFC destination, whatever the data got stuck, it will transfer to the target system here. It will transfer to the target system here. That will happen in the systems here, right? So what we have to do, if any stuck entries, if the functional team asks us to reprocess, so this is the target system, right? This is available now. So just to select that one, there is a option to execute LUW, which means this is called we will call it as the execute LUW here. Then click on the execute button here. So this will transfer the data. Means whatever the entries are there, it will transfer the data to the target system here. So it will check and it will transfer the data. But currently, so connection is not possible via this RFC destination, right? This is failing because of the connection is failing. So because we have to maintain the etc host file in the Linux side, we have to maintain the etc host file. We have to maintain here. So that's the reason the connection test is not possible currently. So I can open. No, it is Windows only, right? It's a Windows only. Mm. Yeah, I got it. 192.162.0.106. There is a etc host. Here we have to maintain the details of 192.168.0.114. So that is the IP. In the etc host file, always we have to maintain the details here. So we have to maintain the details. The ping KPONLINE1. The troubleshooting, right? So now it is pinging this response we are getting here. Now let's do the connection test now here. Okay, connection test. So this is still failing. KPONLINE1 now. Gateway is wrong. The connection test to the RFC destination is not working. So let's find out the reason now. Why? So this is the gateway, and we have now maintained the IP. Let me find out the what is the correct IP. Ping KPONLINE1. Okay, Yeah, I got it. Why? Because the ports we have to maintain in the ECC side. The ports, so the connection is not allowed. So we have restricted due to this previous cyber attack. We have restricted the connections. So that is the reason the connection test is failing. But we can fix it out. So this is the way. You can see user switch is not possible. Now RFC destination is fine. User switch is available. Why? Because this user is different. The caller is different. I am logged in with the different user here. Basis user admin. That is the reason user switch is not possible here. So this is the way we need to fix the issues here. Only technical issues, connectivity issues, we need to check it out. If the data related problems, we have to inform to the our functional guys. So they will take care of the decisions here. But this transactional RFC queues and all, it's a daily monitoring transaction codes here, right? So here we have the only these 4 types of RFCs. So first two normal SM59 connections, but the third one and fourth one we have the transaction codes. One is the SM58. The fourth one we have the SMQ1 and SMQ2 transactions here. So whenever the person, the business users, they will log into the suppose like irctc.com, then they will do the transactions here. The transactions are not only here. It will also send the transaction to the bank server. Then bank server to again, you will get the confirmation to the here. Your ticket will be booked. Like that, the transactions will happen. It's not only one system to do the business. There are the multiple systems are involved here. So that is the reason we can use these systems here. Okay. So this is the types of RFCs here. Okay. So next one, we have 20 minutes left. So that's fine. So we can discuss tomorrow. Okay.